This video is about the historic movable bridges over the Willamette River at Portland, Oregon. This panorama of the city of Portland was done in 1879, as the city's population and business activity were both taking off. It shows the city centered on the Willamette River, and in the distance the Columbia River and the signature volcanic peaks. On closer view, it's fun to look at the city layout and the busy shipping activity. But as we scan along the river, note there are no bridges, which is a big problem for the city residents. Eventually, they started building bridges. The first was in 1887. Because they had to make room for ship traffic, the early bridges were all movable. The first kind of movable bridge was a swing bridge, but it had limitations that were remedied by other designs, specifically lift bridges and bascule bridges. As a series of bridges were built over the decades, Portland ended up possessing an outdoor museum of movable bridge designs. Several are still in use and are at or near 100 years in service. They are the subject of this set of videos. Picking up with the history, we started with this view in 1879. And here is a similar view from 1890. Now there are 3 bridges present. If you can identify them, you are a student of Portland history. Let's name them in the order they were built. The first one was Morrison in 1887. That was followed shortly by Steele in 1888. Third was Madison in 1891. The name Madison may be confusing. It was later changed to Hawthorne. Fourth was Burnside in 1894. Burnside isn't in the original artwork, so I took the liberty of adding it here. The 5th bridge to be built was the Burlington Northern in 1908, but it is not shown on this map. What these bridges all have in common is that they were all swing bridges. Why swing bridges? Look again at the panorama, and note all the shipping activity. The only way to connect the 2 halves of the city without obstructing shipping was to build bridges that could move out of the way of the ships, and the popular design of the time was a swing bridge. So, though the first 5 bridges were all swing bridges, they have all since been replaced by other designs. Let's talk about the design of movable bridges. If the river you are spanning is, say, 100 feet wide or more, you are proposing to move something the size and weight of a road and its supporting structure far enough to clear that space. That is a tall order. But where there is a need, give credit to the inventiveness of the engineers, who came up with not just one solution, but 3. First, you can rotate the span horizontally. That is a swing bridge. Second, you can lift it vertically. That is a lift bridge. Or third, you can tilt it. That is a bascule bridge. Following this in historical order, in the late 1800s, swing bridges were by far the dominant movable design. But they have drawbacks. J. A. Waddell's Textbook of Bridge Engineering from 1916 lists no less than 12 reasons why swing bridges are less desirable than either lift or bascule designs. Without actually listing them all, the major objections fall into 2 categories. 1. A large supporting structure called a pivot pier has to occupy the middle of the river channel. That is an extra obstruction in itself, and it divides the passageway into 2 smaller parts. In this photo of the Morrison Bridge, you can see the large wooden pier under the swing span. 2. Because the swing span has to be fully opened to allow passage of any size of ship, that means it takes 2 or 3 times as long to open and close as either of the other types. Because of those limitations, all those early swing bridges we saw have been replaced by lift and bascule designs. Both are an immediate improvement, providing less obstruction to navigation and faster operation. Lift bridges were the immediate successor. Its advantages start with simplicity of design and operation. Because of the continuous truss, the lift is more stable for heavier railroad use. Bascule is better for lighter highway use. The first large-size lift bridge in the U.S. was the Halsted Bridge in Chicago, designed by J. A. Waddell, completed about 1894. Portland saw its first lift bridge a few years later in 1910. That was the Hawthorne Bridge, which was the third major lift bridge built in the U.S. It has the typical design with a single road deck. 2 years later, in 1912, the same happened to the steel bridge. The old double-deck swing span was replaced with a lift bridge, but an extra feature was added that made this a unique and interesting structure, and it attracted the attention of the engineering literature of the time. It has 2 decks that can be operated separately. There is no other lift bridge like it. Let's take a closer look. The lower deck carries 2 sets of train tracks. The upper deck carries 2 sets of streetcar tracks, a roadway, and a sidewalk. When both decks are lowered in place, clearance over the water is 26 feet. When small boats need to pass, only the lower deck needs to be raised, giving a clearance of 72 feet. When taller boats need to pass, both decks can be raised for a total clearance of 165 feet. The advantage of this is, because it only needs to be partly open for most river traffic, there is considerably less interruption to vehicle traffic. As this was finished in 1912, this year, 2012, marks the centennial anniversary, an impressive 100 years in operation. When the second steel bridge was finished, there was a full house, 2 lift bridges and 3 swing bridges. But that would not last long. 1 year later, in 1913, a 6th bridge was built over the Willamette River at Broadway. This was the 3rd type of movable bridge, a bascule. Here is another fun historic map, this time from 1894. I have circled the rail yard on the left and the steel bridge on the right. The Broadway bridge was built to connect the 2 sides of Broadway, one from each side of the river. On the west, the takeoff point was the intersection of Broadway and Lovejoy. In this aerial view from 1938, you can see the streets of Broadway and Lovejoy meeting at the west approach. Then the bridge passes over the rail yards next to Union Station. Here is a slightly closer view for more detail. Here is a period photo of the new bridge. There are several types of bascule bridges, but we will not describe all of them. We will just identify this as the RALL, R-A-L-L type. Here's a diagram of how it works. The simplified idea is that the bridge leaf, colored orange, is balanced by a counterweight. In action, the movable section pivots around a roller colored blue. If it is well balanced, it only takes a small electric motor to raise the span. Between the several bascule designs used in Portland, I find the Broadway, with all its workings on display, to be more interesting and attractive than its cousins. In 1926, the swing bridge at Burnside was replaced by a bascule, this time of the Strauss type, and in 1958 the swing bridge at Morrison was also replaced by a bascule. The Burlington Northern was replaced by a lift bridge in 1989. Let us briefly review the collection of historic movable bridges. As of 1900, there were 4 swing spans in the downtown area and a 5th just to the north. In this photo, you can see the swing sections of Madison and Morrison. In this photo from 1939, you can see the full evolution of bridge types. Going from south to north, Hawthorne is a lift. Morrison is still a swing bridge in this photo, the last one of its kind. It was replaced in 1958. Burnside is a bascule, then steel, the one-of-a-kind double-acting lift bridge, and the beauty of the Broadway bascule bridge. So, hopefully, you can now appreciate this set of bridges for the historic collection it represents. 3 of these 5 are at or near their centennial anniversaries. You can visit and walk over all of them in an afternoon stroll around the Portland waterfront. In another video, we take a closer look at the Hawthorne and steel bridges.